ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀನಿ. ಪ್ಲಸ್ ಯಾವತ್ತು ಸುಮ್ಮನೆ ಬಂದ ಆರಾಮಿದ್ರೇನಂತ ಬಂದಿದ್ದು, ಫ್ರೀ ಇದ್ರೇನಂತ. ಹಾಂ, 3 ಜನ ಇಲ್ಲಿ ಇವಾಗ 5 ಆದರು. ಇವಾಗ ಅವ್ರಿಗೇನು ಇಂಟ್ರೆಸ್ಟೇ ಇಲ್ಲ. ಕಂಟೈನರ್ ಸರ್ವಿಸ್ EJB ಕಾನ್ಸೆಪ್ಟ್ ಸುಲಭವಾಗಿ ಅರ್ಥ ಆಗಲ್ಲ, ಬರ್ರಪ್ಪ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನೀವು ಇವಾಗ 15 ನಿಮಿಷ ಬರೀ ಅವ್ರು 20 ನಿಮಿಷ ಆಯ್ತು ನೋಡಿ, 15 ಒಂದು 19 ನಿಮಿಷ ಆಯ್ತು 5 ಜನ ಜಾಯ್ನ್ ಆಗಕ್ಕೆ. ಏನ್ ಮಾಡೋದು ಇವತ್ತು? ಸೀರಿಯಸ್ಸೇ ಇಲ್ಲ, ಸೀರಿಯಸ್ನೆಸ್ ಇಲ್ಲ. ಬರೀ 4 ಜನ ಇದ್ದಾರೆ ಅಷ್ಟೇ, 5 ಅಲ್ಲ 4. Okay, let's start. That is left to you. Learning is left to you. Container services. So till last class we have seen the container services, the definition, what is the actual job of container services. EJP container, enterprise Java Beans container services. So you are now today for this class, you are required to act as a developer rather than a client, rather than an end user. Act as a developer. Then you will able to understand a little thing about the EJB container services. Suppose if you are a developer, so rather than if the company or the employer expected you to develop some application, instead of if you start working on a core, you need to concentrate on core functionalities rather than deploying security, how to provide security, how to provide extensibility or reliability of the software. Instead of developing core function, if you're thinking on those aspects, in those cases, yes.
Sir, PPT is not available, sir.
PPT not visible. Okay. So in those cases, waste of manpower will be there. So rather than developing onto a product of which actually needs by the employer, if you are working on something nonsense at the system level, again there is a waste of manpower as well as the cost to the employer. So that's why most of the time the companies are switching to the frameworks. The reason is frameworks which will provide all system level services, they are required to more concentrate on core functionalities. So they are insisting to the developers to work on core functionality rather than the system level services. The job of the container services is that it is providing the mechanics of reliable distributed systems, middleware softwares if it is needed. All those things this container which will provide. The container which will provide the following around. So these are the following specification that EJB container which will provide. That is dependency injection, concurrency, instance pooling and caching, transactions, security, timers, naming and object stores, interoperability, lifecycle callbacks, interceptors, and platform integration. See here, by looking into these are all apart from your main functionality of your business. That is the core functionality which you are going to develop and give it to your employer. Okay, now let us understand what is dependency injection. Okay, when you look into the NetBean itself, NetBean is an actually editor. It supports this dependency injection. It means that if one interface is created for the local, you have worked with EJB, that entity beans, right? If you create a method to accept the value from the client side, that method should be included in the local interface, right? So that dependency injection is nothing but it is a component based you approach to software design brings with it the complication of intermodal communication. So intermodal communication, as I said in the previous session example, so Amazon services for shipping order to till the reach the item to the customer, there are a lot many processes involved. So ordering, verifying the accounts, payment details, and ordering quantity, stock management, all those things which is involved in just accepting the order of the customer till delivery. So this inter-module communication, one module is depending on another module. Such kind of the model, if you develop a code in such a way that if it is tightly coupled, if it is tightly coupled, then it is very difficult to do that kind of the application to provide all the services. If you want to reuse the some of the component of those, it is not possible. Again, you need to develop from scratch. Rather than that, if you go with the component module approach, so that component module should be loosely coupled. So then you can make use of them wherever it is required. See, tightly coupling discrete units together violates module independence and separation of concern. So, it's a very good example is actually order shipping. Order shipping. So, order accept. The next is process order, processing order. The next step is then payment verification, payment verification. The next step is stock management, stock management. The next step is then shipping, shipping. The next step is then delivery. This is one e-commerce, any one e-commerce, not only Amazon, any e-commerce application which needs these inter-module communication. So there is sometimes order acceptance after while accepting the order itself, this process order and the payment verification which will happen. In that case, if you follow the tightly coupled fashion, it means if order comes here, that request comes here, sometimes because within this series itself it is going to complete, sometimes it is required to check the stock management directly after accepting the order. If you are skipping these two inter communication, if you build a code which is tightly coupled, means it won't allow you to skip from this step to directly this step. So that's the component based approach. Is it's a loosely coupled modules, right? So tightly coupling discrete units together violates module independence. This module order is this module is independent, process order is independent, payment verification is independent. If you tightly couple means it violates that module independence and separation of concern. Separation of concern. So sometimes order accepted directly delivery. So internally it process. So if you need to do that separation of concern, you are going with this dependency injection. You are specifying which are the models are dependent of each other, and whenever it is required, you are creating that dependency injection here. As EJP is a component-centric architecture, means it is loosely coupled. It provides a means to reference dependent models in a decoupled fashion. in a decoupled fashion. The end result is that you will adhere to be a contract and let the container provide the implementation at development deployment time. See, to provide the loosely coupling of the component model, you can restrict the contract terms. For example, take the Airtel users. So if you recharge for 249, 1.5 GB, I'm not promoting any of the those things. Just for example, say if you pay for 249, they will provide a service of 1.5 GB per day and unlimited calls and 100 SMS free for 28 days. Your contract is going to be complete in 28 days. After 28th day onwards, 29th day, your services is disconnected. Getting? So, if they configure for the user who is recharging for 500 or 599 plan, 84 days contract. See, for individual users, depending on the user payment type, they are providing a services. It is possible to provide such kind of the services through the component centric architecture. If you made it fixed for everyone is common, even though the payment differs, then it becomes difficult for the users as well as the application uh, um, application users. Getting? So dependency injection is developed in such a way that which model is dependent on which model. But the same model can be used for the some other instance for other set of contracts. For example, pseudocode, how dependence model is, for example, suppose mail user is a function you are defining. So mail user sends a mail is the definition you define. Now this mail user functionality, it is dependent on which module? User module. How you say it is dependent on user model? Since the any e-commerce, when you log in and order shipping, if any complaints or any correspondence if you want to make to them, either you can send through your Gmail account or you can send through the mail which is defined by them themselves, customized mails. So user module is dependent on which function? Mail user. You can make this mail user module as a dependent module to the user by adding the annotations. Which annotation? Dependent module annotation. Getting? In this way, you can create the dependency injections. The fictitious dependent module annotation serves two purposes. One is defines a dependency upon some service of type mail module, and moreover, the code is titled here between this user model and function mail user. But these two are independent modules only. Still, it is the module exists is independent only, but functionality it is dependent. So some other user or the developer wants to make use of this mail user, they can make use of this because it is independent functionality. Getting my point? This is dependency. Defines a dependency upon some service of type mail module. So module may not deploy until this dependency is satisfied. So whenever you are deploying the application and start using, authentication happens. If this mail user is properly exists with the application, then user can interact with that interface to send a mails to the e-commerce business. This marks the instance member mail as a candidate for injection. Who is the candidate for that injection? Mail is the candidate for that injection. The container will populate this field during deployment. Dependency injection encourages coding to interfaces and not to any particular implementation. So they are creating the interfaces rather than directly injecting onto the direct coding. So through interfaces, you can interact, you can inject any of the functionality, individual functionality modules to any of the deployment stage. Getting, so the interface role is to interface that you are not directly injecting the code which is depending on the other module. If you do that, there is a deny access which it will arises. If you directly inject the code, that is the core code to the application, it will show the deny access for other deployment users. So because otherwise deadlock state, there is a possibility of arising deadlock state. To avoid that, through interface concept, you are going to deploy those modules. Is it clear? Any questions with respect to this? This is a very important concept, dependency injection. No questions, right? Fine. Next, concurrency. It's the second specialization of the container services, that is concurrency. So concurrency is assuming, concurrency means parallel execution. So in these concurrency, there is a possibility of deadlocks, live locks, and race conditions which will arises when it is deployed. Suppose if you are creating the dependency injection to the direct to the code rather than interface, obviously there is a possibility of accessible deny or the possibility of deadlocks if that application uses the database concepts. Obviously any e-commerce means it is interacting with database only. So assuming each service is represented by one instance, dependency injection alone is a fine solution for single threaded application. So dependency injection is alone fine solution for single threaded application. If it is single thread model, so dependency injection is fine because it is tightly coupled. But only one client may be accessing a resource at a given time. See, if the Amazon is designed in such a way that they are allowed the multi-client accessible at a same time. So still they are using the dependency injection until unless the mail is loaded, user cannot log in into the application. That is dependency injection they have made, right? So they are providing the multi client services to the application. Here concurrence, however, suppose if it is single thread model, single user, if you want to support, you can go with the same dependency injection and concurrent service. However, suppose if quickly becomes a problem in situation, when the situation comes, centralized server is fit to serve many simultaneous requests. For the application point of view, this is right and good. For the server point of view, there is a possibility of multiple requests is handling, right? So to handle such requests, there is a possibility of going deadlocks, live locks, and race conditions are some of the possible nightmares arising out of an environment in which threats may compete for shared resources. See, the in real time scenario, container which is providing lot many services to the clients, which going to request for that kind of application. So in addition to that, it has to take the load of managing the transaction happening parallelly. Each transaction might uses the new thread interfaces to interact with the application. So there is a probability, chances is there, there is a chances is there, that is deadlock chance, live lock chance, and the race condition chances. Then EJB allows the application developer to sidestep the problem entirely thanks to series of concurrency policies. These situations. To avoid these situations, EJB provides the concurrency policies before accessing the any of the modules and any of the database services. First, it is going to check the concurrency policies whether it is allowed or not. Through the concurrency policy, the container service which will provide the concurrent access of the resources that is exist with the EJP container. And the third specification is instance pooling and caching. By looking into the diagram, you are able to understand there is a possibility of instance pooling. If there is no instance pooling, obviously the previous problem which will exist. If there is an instance pooling, means it is allow you to execute the individual request in a queue fashion. If it is a single thread that needs to be queued. If it is a multi-thread interface is defined, so all the request which is going to be handled. If still remaining means other request has to wait in the pool of service. Once the existing request service happen, remaining is going to be processed by the container services. That is instance pooling and caching. So, because of the strict concurrency rules enforced by the container, an intentional bottleneck is often introduced where a service instance may not be available for processing. So if the multi-use request, for example, in the offer period, Dasara offer, Deepavali offer, the Christmas offer, Ramjan offer, in those cases, huge hit request will come to the e-commerce business. In that case, container services needs to handle. So they need to maintain all the requests. Otherwise, the e-commerce business loses the customer who is hitting the their website, right? They don't want to lose the customer. They need to handle such situations, the heavy load situations. To do that, this instance pooling and caching mechanism to help to provide the services for those kind of requests. If the service was restricted to a singular instance, all subsequent requests would have to wait a queue up until their turn was reached. If it is a single thread model like a ticketing system in the movie, in the online booking, it is multi-threaded again. Now come to the general scenario. Come to the physical theater system. In that case, one a ticket will be issued at a time. Even thousands of people are crowded, assembled there in front of theater. They need to wait to get the tickets. So that is one window system. Getting one window provides the one service at a time, one ticket at a time, right? So that's the model of that instance and pooling instance pooling and caching in EJB container, which will provide the services for bulk requests also, which is coming from the client side. This is the fourth specification of the EJB container. Clear? So one is dependency injection. So in the dependency injection, there is a lot of modules are involved. There is a possibility of skipping one of the modules which is not necessary to process. In that case, dependency injection is helpful for that. So if you are not going with dependency injection, the code is going to be bounded. In that case, only one request can be handled. Through the concept of interface, they can handle the multi request which is coming from the client side. The dependency model, dependency injection. Then concurrency is the if it is single thread interface implementation, there is no concurrence thread exist. So if it is a multi threaded interfaces, possibility of problem which will arises during the runtime of the application. To avoid these conditions, you are going with the concurrency policies. These policies defines depending on the policies which exist, the user is going to access the resources. And the instance pooling, it will works for again multi-threaded interfaces, multi-threaded request. If single service window is there, all the request is has to wait in a queue model. Otherwise the all the request is going to process at a time. It depends how the implementation is being done by the developers. So look here, you will clearly understand this. So if in this case, in this model, in this figure, single service man is single or server is single, one single container, multiple request is coming. So each request is completing one at a time. That is the queuing service. Come to here. So parallel service, one service, multi request is handling at a time. So till it reaches the maximum number of service, it is able to handle. It is max plus one service comes, that service has to wait in a queue like in this model. Multi single service, multiple request, capability depending on the capacity of the services which it is defined by the developer, it will handle. Then after that, it is that all the services, either it is services may be denied or the services may be defined under the instance pooling and caching. If it is defined under that, all the services, additional services is it is going to be queued. Otherwise service deny or service drop will exist. If the service was permitted to use any number of underlying instances, there would be no guard to say how many requests could be processed in tandem, and access across the physical machine could crawl to a halt as its resource was spread too thin. Because service, single man is handling. How many? So in real time example, one man can handle how many peoples in really in management style. So up to 1000 or 2000 man he can handle. So if 3000 4000, again assistant management will come, means second service will come. If that kind of service not exist, so other the 2000, after processing the request of 2000 2001 request will become, otherwise that request is going to be dropped. Means that is a flaw in the application development. To avoid such things, instance pooling and caching is used. Here in this diagram, in this service, in the service model itself, there are many instances that are present, service of instances. The each instance may provide the thousands of process of the request sent by the client. So in a special scenario like Deepavali or the New Year scenario, more number these kind of the architecture is used with the help of the EJP container services. See, by looking into the text, you can able to understand. EJB addresses this problem through a technique called instance pooling, in which each module is allocated some number of instances with which to serve incoming request. So, in a single service or the multi-distributed architecture, multi-service servers, different instances are maintained. Each instance can can handle the many requests at a time. Still, any remaining request, those requests is going to be cached. That is called as instance pooling and caching. That is supported within the EJB container. Okay, so many vendors provide configuration options that allow the deployer to allocate pool sizes appropriate to the work being performed. Okay, so again it is configuration dependent, depending on the infrastructure available and deployer. So based on that specification, you are going to handle the request with the help of this instance and instance pooling and caching. And the fifth specification is transactions. Very good example for this transaction is banking transaction. So banking transaction involves lot of things. First of all, it should support the acid properties, atomic, concurrency, isolation, and durable. Means that that transaction should support all these property. So otherwise, what happens? There is a possibility of transaction failure. In that case, the client or the bank, either owner or the client or the bank, client or the bank is going to lose the money in case of transaction failures. If that transaction won't support acid. So, to handle those transaction related issues, EJB uses the Java Transaction Service module. It is an API. Java Transaction Services is an API, means built-in functionalities which is defined under this API to maintain the transaction services. I am not talking EJB concept means a complex. I am not talking a simple application. It is a complex to the real-time applications. So in that cases, if you need to define the payment gateway interfaces, you need to include the APIs which is supported for the gateway interfaces. See, EJB ensures this via its integration with the Java Transaction Service. So that is JTS, and exposes an API that gives the bean provider control over the properties specifying how a transaction aware application behaves. So for example, take the your debit card. Your debit card, what is the property of your debit card? Debit card number, then the debit card which will have a chip and along with CVV number, right? So when you insert the debit card onto the ATM service, what is the next step? You need to that machine should identify your card is valid or not. If the card is valid, then it will ask select the one of the transaction. So you need to enter the PIN service. That is verification one. First verification is valid card or not. Second verification. Second verification is you are the correct user or not, whether that card is belonging to you or not. It will do the verification by asking the PIN service. After entering the PIN, then it will ask for the transaction whether you want to do deposit or the transfer. So or balance check or statement generation, again it will ask the statement if you go with that deposit transfer or withdraw. So click on withdraw, then again it will ask from which account, either current account or savings bank account. So again the verification, again so savings bank account, then to which account you want to transfer, you need to specify the account number. Again it is asking to re-enter the same account number second time to validate that whether you are sending that particular account or not. See, these all the things are involved in single transaction for single person. So one at a time, ATM machine is a single module is one at a time. It happens, but at the bank end side, bank server side, multiple requests is coming from different ATM machines. All those can be that should be handled without interacting. For example, so transaction failure when happens abruptly if you are removing the card from the machine without canceling the transaction, or there is a possibility of power failures. Probability, this one power failure. In that case, again transaction incomplete happen. That transaction has to maintain the consistent state. Either the previous state is consistent or the current state is consistent. If current state is consistent, it retains the same transaction. If the previous is consistent, the whatever the transaction, all these steps, it should be rolled back to the previous consistent state, right? So these type of the transaction related queries which will be handled through the JTS. This JTS is an API interface which is developed by the which provides the business services with the help of the EJB. So EJP developer is required understanding of asset fundamentals. What is asset stand for? Atomicity, consistency, isolation, and durability. So atomicity nothing but every instruction in a call completes or none do. Means if transaction is happening means everything should be completed. Otherwise nothing should happen. Either completion or not completed at all. Complete. If there is a failure halfway through, state is restored to the point before the request was made. The rollback should happen if not something happened in between during the transaction. Then consistency, the system, that is transaction, what it is happening, the system will be consistent with its governing rules both before and after the request. Suppose if you want to cancel the transaction in between, you can cancel, and it may takes you to the home screen. If it is not, if it won't takes you to the home screen, or either it should take you to the home screen or the logout screen. If it takes something else, some other screen which is nowhere related to your transaction, if it takes you means that system is not consistent. So consistency should be supported by the system. Then isolation, whatever you do transaction, each individual transaction should be isolated. Means suppose let us take withdrawing money of a single person. For example, your dad account. Your dad is also withdrawing, you are also withdrawing at the same time. Is it possible? Same time, exact 11 o'clock, exact 11 o'clock. Both are you are trying to withdraw money. Each individual transaction, it is treating it as a isolation. Otherwise, again there is a possibility of deadlock. So if in a balance of your dad account, if he has 10,000 in his balance, if he has given authority to you to withdraw, he is drawing through the check bank counter, you are drawing through the ATM machine, right? Suppose you are drawing the whole 10,000, your dad is trying to draw for 5,000, but in the account how much amount? Only 10,000, right? If the both transaction comes at the machine counter, first it takes the 5,000. Why? Because 5,000 is the, according to bank policy, you have to leave 1,000 rupees in the bank, and remaining 9,000 can be withdrawn. So this 5,000 is satisfies the condition of the bank. So they are processing this first 5,000. Then remaining balance is going to be updated onto the database. That database is going to update it as new balance as 5,000. Now it will take your transaction 10,000. 10,000 according to bank, 1,000 is you have leave in the bank account. Remaining 4,000 you can withdraw, but your transaction amount is 10,000. They are going to reject by saying that insufficient balance. Means individual transaction, if it happens at the same time, there is a possibility, less possibility, but there is a possibility. In that cases, it checks with the consistency, it checks with the atomicity, it checks with the isolation. Each independent transaction should be isolated. Otherwise, there is a possibility of deadlock condition. So durability, Once a transaction successfully returns, it must commit to its changes. Once your further withdrawal happens, that remaining balance should be updated onto the database. That is durability status. The system must process the results once a client has received word of normal completion. See, this asset property supported by the JTS, which is comes along with the EJB container. So what we discussed today, dependency injection, then dependency injection,
Concurrency.
what we discussed,
Concurrency.
concurrency,
Instance pooling.
concurrency, then uh, instance polling and caching, and
Cache.
transaction. Okay. Any questions? Is it clear?
Yes, sir.
Fine. That's end today. Tomorrow we are going to discuss the remaining the container services. Okay. Remaining container service, security and onwards. Okay.
Um,
Ask others to join quickly to the discussions. And those who enter late also you enter your USN and name in the chat window. Okay. Thank you.
Thank you, sir.